You're fully capable of doing what you could totally. We're ready to go. You're welcome. Sorry.
Okay, let's get started, and welcome to our weather discussion for today. First thing I want to say is I think I've got 4 people in here from 751. You guys need to pair up and give a discussion, and I think the only way we're going to really be able to do that is here. So one thing we will do, I won't be here next week, so we can do it on the 17th and then on the 1st of December, I think. Could be 2 days that we do this. And there'd be one group of 3 and one group of 2. What else was I going to say about that? We won't broadcast those discussions, so the pressure will be lower. Okay, so there'll be no live stream feed on those days, if you don't mind. And rest of the world, too bad. That's just the way it's going to be. It's part of our curriculum, and you have no say at all. So that's how we're going to do that. Okay? So let's start with the week-long animation. This has lots of little clues in it about how some interesting things have been going on around the hemisphere, not just over us. Let me begin by saying this. The September 1 through October 31, cold pool, 3rd warmest ever in 76 years. Pretty wild. So we made a run for number 2 for a period that we were there, but we kind of come back to average, and that got us out of the running. But the number 1 year, 2000, what was it? 11, is way ahead of us in terms of deficit, and then 2007 was a close, 2005 was a close run. We almost tied 2005, but not quite. But that's just an aside. And it's gotten colder here. That's the big weather change this week. So over the weekend, you know, last Friday we were in here, it was like a sauna, and it was the 3rd day of sauna-like conditions. You know, it was too much for me. I was at my wit's end, but I knew what was coming, so I felt good about that. And then we had a 1/10 of an inch of snow on Tuesday morning, Halloween. So that was measurable snow. The first measurable snow of the year was October 31 this year. So I don't know if there's any pools going around, but that's usually a fairly early date for that. And then the next morning we got down to 20 officially at the airport, as it turns out. So really cold to start, you know, the beginning of this month. October ended up about 1.5 degrees. What was it exactly? I can't read this until I go like this. 1.8 degrees above normal, 0.6 for highs, 3.1 for lows. So we were warmer overnight more often than we were warmer during the day. And that's a characteristic of the global warming era in a lot of places. And our month of October was no different that way. But one of the things that was related to the ushering in of the cold air early in the week, we'll get close to the end of it here in a minute, you'll see there's going to be a rip-roaring jet. And you see cloud evidence of it in the infrared with that when it cuts through. Here we go. Getting that. So the cold air was looming to the north a week ago, and then it made its way slowly through in the weekend, and here's the jet. And you can see it kind of take shape, at least in the cloud features, and it races across the North Atlantic. And here comes our little swirly on Tuesday. Beautiful little storm, wasn't it? It's just gorgeous to look at, and it gave us that little bit of snow. I hope you got up early enough to see it snow, because we only had a flurry in the mid-morning, but it snowed reasonably nicely from about 5 to 6, and I saw the tail end of that. I didn't see the beginning of it. So that was nice. But this jet, in conjunction with a couple of disturbances brewing in the tropics on its anticyclonic shear side, set the stage for some really interesting interaction between tropics and the extratropics about in the middle Atlantic, and it took off. Explosive development just south of the British Isles on Wednesday night into Thursday. So they had a tremendous brush with a storm called, I don't know how you pronounce it, it's like an Irish name, C-I-A-R-A-N with an accent at the end, like Kieran or something like that. Anyway, brutal storm. Lowest pressure recorded on the Channel Islands was 950.5 millibars. So it's the lowest November pressure ever recorded in the in England. Now, they had a great storm in 1703 in November. They don't think they had a lot of barometers around, so they may just not have been a good measurement then. I bet you that one beat it. But Pete's got this horribly disorienting animation that somebody thought was a good idea. It's not a good idea. You need context for everything. So anyway, you can watch some of the features somehow get their act together. We will, of course, do a better job of that today than was done here. But I know this was piecemeal, so not so easy to stick with it. But thanks, Pete, for bringing that in. So we're going to talk, part of what I'm going to talk about is the Siren. And we'll say a little bit about how that all developed. But not before we take a look at our own current conditions. So, Pete, let's start with just a satellite movie for the last 6 hours over us, if we could. So here it is, just the last bit of it. And all the action's over in the eastern part of the Atlantic. But here's our cloud mass over us this morning. A couple of rain showers. I don't know if it's still raining now, but it was at around 10:30 or so, just when I walked over to get a bottle of milk. And but not cold enough to snow, which is always, of course, unfortunate after we've already had a brush with it. You can see this very cold air, but it's now placed well to the north in the northern parts of the prairie provinces and into the Yukon and the Northwest Territories. So these are clouds, that's just cold air. That's all that is. And really cold, but far away, so we don't have to worry too much about it. We'll see a decent looking storm developing off the Pacific coast. This angle, this view is not as good as the one we'll get in just a second. And then clouds across the Great Lakes states and just to our west. So we'll take a look at that in some detail as well. Let us now take a look at the West Coast satellite image, if we could, Pete. So this is a decent looking storm. And it's kind of putting itself together nicely. Something went wrong with my Omega calculations this week on the web, so I don't have anything to show you on that, but we can do a little diagnostic in another way without the answer. But it's a beautiful looking storm, and it's the first really decent one that's made it up towards the Pacific Northwest. And it may be the last for a while, is what it looks like to me. And here's the ITCZ flaring up across many of the longitudes in this sector, except far eastern Pacific, where it's not quite revved up. But a pretty decent looking storm just off the coast of Washington and Oregon, and it will impact those two states, especially the western portions of those states, as we move into the early part of the weekend, that's for sure. Although this thing, we'll see, perhaps in the forecast, I don't know if Patrick will pay any attention to it, it does decay rather rapidly. It doesn't really hang together. It's not going to crash into the coast as a major storm. It looks better now than it will a day from now, I think. Okay, can we, Pete, let's look at the national radar before we go to anything else, just to see what's going on here. And you can see the scattered showers. One of them, pretty decent one, came through us. That must have been the one that rained on me. There may be more coming during the day, but they're going to be few and far between, it looks like. This is not particularly well organized. I don't know, we'll look at a surface map in a minute, if any part of the state is seeing this precipitation fall as snow. I doubt it, but I don't know that's not the case. And then certainly down here in Nebraska, it's not snow, I'm pretty sure of that. And that's about all there is on the east, in the whole continental United States, really, just what's going on over us. A little bit offshore, as we just saw, and then some light showers coming in off a fairly active, convectively active southeast Atlantic coast. That's been the case most of the week. Okay, thanks, Pete. Can we take a look at the surface map, just to check on what kind of precipitation is falling, if there's any variation among it? Well, some snow on the Northwest Territories, who cares? Of course, that's going to be the case. I'm more interested in our own region. So, first of all, light rain at Green Bay is about the only observation of rain at this particular hour, and that's 48 degrees. So, well warm enough that everybody's getting rain who's going to see precipitation in our region. And then further west, the showers are so scattered that really everybody's just cloudy but not reporting rain. So we may see, and partly because you've got a 21-degree dew point depression in many of these locations. We have a 14-degree dew point depression. So the boundary layer is very dry, and so maybe precipitation is just evaporating before it gets to the ground in those places, even though the radar is, of course, showing something looks like it's falling. So that's probably what's going on in some of those places. On the other hand, you just can't, you don't get a report of rain at every single location in a broad region where it might be scattered showers. So that's another part of the story. Okay, pretty nice day for early November across much of the country. Temperatures everywhere in the mid to high 50s, even some 60s as you go farther south into Oklahoma and Texas. Same in New England, and dry, so pretty nice day. And I think that's true all the way to the West Coast. So it's a pretty decent, moderate day for early part of November, as you can see. And we're a couple hours behind time over here, but the whole coast of California is in the 60s and 70s. Even the West Coast, without rain right on the coast, is 58. It's saturated down here at Cobell. 49 over 49 at Kurt Cobain's hometown, and so it's all pretty miserable, as usual. but that led to Nevada. It did. I mean, it really did. I mean, he lived in a miserable place. Actually, I pointed out the wrong place. He lived in Aberdeen. If you've ever been to Aberdeen, oh boy, that's not the nicest place to live.
Aberdeen, South Dakota?
Huh?
Aberdeen, South Dakota?
No, Aberdeen, Washington, right on the coast.
Oh, okay.
Yeah, it's cloudy a lot of the time. Okay, let's go to the 500 millibar super peak. And so here's this morning's map. All the action is off this map, so there's not much of a point. I looked at it myself to look at a movie of all of this, and it doesn't really demonstrate what I hope to demonstrate. We'll go somewhere else for that. But we have a really deep upper trough sitting right over Hudson Bay. This is the beginning of the establishment of the climatological Hudson Bay low. So it's just about on schedule. And the actual details of the Hudson Bay low determine a lot about our weather at this transition time of the year. I mean, if the thing gets established early and it has these little spokes out to the north and west and they rotate through like this one here is doing right to the east of Lake Winnipeg, that can bring little shots of cold air. This one did not get far enough south to really impact us. But if you're up right in the Boundary Waters area or in southwest Ontario, you had a pretty nice weather change over the last couple of days where it got a little bit more autumnal, maybe even slight wintry light in these places compared to what you had earlier in the week. We're preserved from that. This little wave is going to slide to our north. I think this one, if it develops into anything, may have the same exact sort of fate. And we have this sort of tendency for mostly westerly flow. And when the flow gets westerly to our west, then we end up warming up, and we're doing that already. So it's kind of a nice change from the cold day for most of you, not for me. But you know, I'll sacrifice that for the benefit of the group. I'll get my day. I'll get my day. But anytime the flow, that's just as a way to look at the winter weather. Anytime the flow gets westerly to our west, it warms up every single time. There's no exceptions to that. Partly that's because of subsidence in the lee of the Rockies, which produces a warm bubble and gets advected by that westerly flow. And part of it's just that the really cold air is to the north, so you need northwesterly flow to stay cold. And that comes in starts and stops for us during the wintertime. Here's the upper wave associated with the cyclone that we saw nicely presented in the satellite movie. You can see the thermal structure at 500 millibars. Never usually the best place to look for that structure, but even in this, my experience suggests to me this is a kind of a dilapidated system. It's not really well put together. It's fairly sharply curved. It's got some strong shear at the bottom, so the vorticity is robust in this location, and probably the PVA is decent out ahead of it, and so that might be the developmental mechanism right now. But I don't like to see such a dilapidated 500 millibar thermal structure. Makes me think I don't have much hope for that to maintain strength or get any stronger. Let's go down to 700 just to get a peek at a closer lower tropospheric description of that thermal structure. And I have the same impression. There's a little bit of baroclinicity on the north side of the cyclone. Perhaps that's slightly frontogenetic, but really the rest of the structure is just absolutely absent. So I wonder how much PVA by the thermal wind is actually going on down shear of that 500 millibar trough, because there's just not much thermal structure. So it's maybe already at the point where it's not going to have much to say about the future of the weather in Washington and Oregon. But even at 700, you see, I should say, at 700, even more expansive signature of that Hudson Bay low. And it's the dominant feature over the continent right now, that's for sure. We're on the south side of it, so we're not desperately cold. And with the westerly flow at mountain height at 700 millibars, it's really hard to get cold when the flow is mostly westerly for us. And I suppose that's a good thing for all of you. Okay, let's see what it looks like at 850, Pete, if we can see any more structure to the feature out over the Atlantic. There's the big cyclone. Here's Greenland, the tip of Greenland, so to the southeast of the tip of Greenland. Really intense baroclinic zone, comes all the way down. Cold front is just past Miami at 850, tied to the cyclone south of Greenland. So, you know, Michael and I had long-standing arguments, which of course I won, about how intense these extratropical storms are compared to these tropical things that are, you know, a couple hundred kilometers across. Give me a break. This thing rules the roost. So does this. This one, not so well put together, but hey, you know, you can't win them all. So, decent cold advection at 850 is something of note. But notice, and that's only in the northern parts of North Dakota and Minnesota, Look at this wind right near Minneapolis. It's just about parallel to the isotherm. Same at Green Bay. Same almost at Rapid City. Not quite. It's a little bit of cold advection there. But that's really where the cold advection ends. Even though the baroclinicity goes all the way down to northern Nebraska, the temperature advection associated with it stops about there, at the South Dakota-North Dakota border. Preserves us from, I think, from the risk of getting colder. But that's a subtlety that is something that you really got to pay close attention to on the map to see that. Because otherwise, you might say, whoa, strong baroclinic zone with northerly flow over Lake Winnipeg, watch out, Wisconsin. I don't think so. And here's a little bit of a warm bubble with a geopotential height trough. I think that's a lee side trough in the lee of the high terrain of the Rockies. And so that's the competition. There's warm advection actually to the northeast of that feature, and then there's cold advection to the northwest, and we're kind of right in between the two. Maybe that's why we had the clouds today, right? Differential temperature advection is phenogenetic, and it's right in that band. Okay, what I think I want to do next, Pete, that's just an overview of what's going on over us. Can we go to Alicia's maps? I didn't bring it up, sorry, I thought that I had, but I did that upstairs, not down here. And we'll go to the North Atlantic. We had a really good weather discussion in class yesterday by Ella and Eleanor, and we were talking about the second of two storms that are fairly impressive in the North Atlantic. And the first one was, however you say it, Ciaran. Maybe that's Gaelic for Karen, I don't know. Let's go to North Atlantic. No, really, it might be. I think it might be. And let's go back a few times. We'll go back to 12Z on the 1st, if we can go that far back. I think we can. Actually, 12Z on the 31st. Sorry, I meant that. Perfect. Okay. So, here's a strong jet. Remember now where this came from. This is the sagging cold air mass, because here we are in Wisconsin. This is the sagging cold air mass that settled through us over the weekend. And this is the blue and red lines are 1,500 thickness, so really intense thickness contrast. And we used to, last week we were on the warm side of it. By the time we got to Tuesday, we were on the cold side. And there's our little cyclone that spun through us that morning as well. And a strong 250 millibar jet in the shading. So that's the setup over the eastern part of North America and the central and western North Atlantic. Look at this little cyclone that's kind of really oddly shaped. It's sort of a, I don't know, it looks like a hot dog bun or something like this. And it's south of the south of the jet stream. It's on the anticyclonic shear side of the jet. If you're looking for the place where the wind speed maxima decreases most, it's probably right off the coast of Newfoundland. And so you're in the right jet exit region, which is a bad place to be if you're a cyclone, because that, at least from the wind speed changes, is going to force upward convergence and subsidence. So you're really in a bad spot from that perspective. However, you're in a region of really strong thermal wind. So the question is there any vorticity maxima in association with this? So I'll put my pointer here. I'm doing it the opposite of the way I usually do it. That's where the surface low pressure center is. Remember how the thermal wind is oriented. And let's go to the 500 millibar vorticity peak, which is right there. And really, you're hard pressed to see a really strong feature. It's maybe this thing over Newfoundland, but I don't know if that's really got the right orientation and setup for developing this cyclone at this time. And if I take the pointer away, you even have a little bit of anticyclonic bridging in the 500 millibar geopotential height lines. So this is like a really bad place for a storm that's going to bring 90-knot winds and the lowest sea level pressure ever recorded over inland a couple of days later. Doesn't look like a good spot. And it's not going to be this little vortex. That's the one that gave us our snow. That's not in play. Okay? So how's this going to work? Well, one thing you do notice about this map, thinking about the thickness lines as proxies perhaps for the 500 millibar isotherms. We won't have to do that. We can look at the actual data in a minute. But there's a region of cold advection in this cyclonic shear. And that's a really good way to force air downward from the upper troposphere into the middle and lower troposphere. And that might actually intensify this upper vorticity maxima by virtue of bringing high PV air from the lower stratosphere into the upper troposphere. So let's do a couple of clicks ahead and watch this region right here, where that might be where the action is. It doesn't really look like it's done anything. One more click. Then you start to see, hey, this is getting a little bit more orange and red. So we're getting into the higher end of the scale, maybe 2.5 or so times the Coriolis parameter. We'll stay here for the moment. We still have, at least by the thickness and geopotential height lines, geostrophic cold advection and cyclonic shear. There's no wind speeds here, and the wind speeds are 100 knots right here. So there's a lot of cyclonic shear there. And this blue, incidentally, is the vertical motion from the model. It's not a QG vertical motion. But you start to see a little bit more, perhaps penetration downward of the high PV air manifesting itself as a vorticity maxima in the upper troposphere. And that's starting to look a little bit more interesting. Let's see what the sea level pressure looks like at this time. I'll keep my pointer there. Oh yeah, we got a little disturbance right in that spot. And it's down to, this is 984 milliwatts. And it started out at about 1,012. So we're only, what, 18 hours downstream of that original time. So this is a pretty decent cyclone developing here. Here's the British Isles and the north coast of France, Brittany, Brest, all those places. Okay, let's go a couple of clicks ahead at sea level pressure. Look where the cyclone goes. Well, how does it migrate polar to the jet core? And then it puts itself suddenly in a spot where it's not a really strong force in here because the wind speed decreases kind of, metered out over long distance, but there is an exit region of the jet in this location, and that's where the storm really goes to town. Look at this. Right there, this is 984, 80, 76, 72, 68, 64, 960. Right there. Just about to enter the English Channel, okay? Right now, there's wind speeds in excess of 70 knots over northwestern France, and waves of 60 to 70 feet right off the coast. Let's go one more click. Whoa, 984. So this is 976, 72, 68, 64, 60, 56, 956 down near the far southwest coast of England, the best place to live in England, some people say. And really strong winds, even stronger on the southwest side, just about to hit Brittany. So they got hammered. They got 100-year-old trees knocked over. 5 people died. All of them died from being hit by trees falling over. All of them. And then many of the injuries were like that. And so in the English Channel is shallow and strongly confined by land. If you put 30-foot waves in the English Channel, which happened this weekend, 30 or 40-foot waves, that is chaos, okay? This week, I should say, it happened this week. So that's a really intense cyclone. It's brought a lot of damage to southern England and northern France. Parts of Spain even suffered from this thing. So this was a really intense development. And what's cool about it is it migrated across the jet into the left jet exit region, having begun in the right jet entrance region, exit region. And then you can see there's a big wave, a big humpiness to the jet that's developed during this period upstream of the development region. So it's a really intense storm. We'll look at a couple of things from this in Viz 5D, but not too much. Then Eleanor and Ella told us about this one yesterday. And look where it's starting to develop, on the anticyclonic shear side of the jet. And this is yesterday at 0Z. So that's developing on the southern side of the jet, much like Siren did, but a totally different orientation of the jet. Many of the same characteristics. Intense baroclinicity. I think, let's see what the 500 millibar vorticity looks like for this one. Again, somewhat far removed from the location of the cyclone center, right? This is the upper vortex is really not in play for this development yet, okay? And then let's go back to sea level pressure and go a few clicks ahead, Pete. So they're already cleaning up over there for the first storm. Let's go ahead and watch what happens with this one. So look at it. Oh, what's this doing? Cutting across the jet again. Finds itself in sort of the left jet exit region, and that's where it goes to town. So this is 16, 8, 1,000, 92, 88, 96, 92, 88, 84, 80. 980 millibars just off the coast of Newfoundland. Okay? Intense cyclone, and let's see what the vorticity structure looks like now. Can't remember the answer to that. Yeah, now we're kind of in conjunction with the cyclone, right? So here, we're in a region of intense upper vorticity, strong PVA by the thermal wind, and here's the cloud head upward vertical motion. So a really intense disturbance. Let's go back to the sea level pressure and take a look at how that feature evolves. So we were at 980, it's more intense. Look, you don't want to be in a ship right here. And, here's what the Titanic did. It went like this. This would have been the spot where it was. Do you imagine how high the seas are there? 60, 70 feet. Incredible. Keep going. Look at this. These are hurricane force winds in this region of pressure gradient. Okay? Hurricane force wind. And then it suddenly kind of dies. The whole jet structure gets weaker. Let's keep going. And this strong pressure gradient still. But the whole cyclone is not going to be as intense for the Channel area and the southern British Isles, but it's not going to be a wimpy storm either. They're still cleaning up, and they only have a day or two to do it because this next one's coming. Okay? And really nice thermal structure. This one's deeply included. The first one was not. This one's deeply included. Beautiful structure. So it's going to be raining heavily in northern France and southern England by the time we get to the middle of the weekend. And look at how extended the barotonicity is across the Atlantic. Again, with a little bit of a respite finally coming. But this has been a stormy period. And a couple more clicks, Pete, if we can. So we'll see how it's going to be more of an impact, I think, again in northwest France. Brittany is going to, and maybe northern Spain, the Basques are going to go crazy when it gets windy there. That's not good for them. And if you happen to, this is the place to go, Nazaré off the coast of Portugal. There's a trench in the Atlantic right there. They have 100-foot waves that are spawned by storms way out to sea. It's going to be wild there this weekend, and people go surfing there. So someday I have to go there and see these waves. You can find them on the internet. You've probably seen them. Pictures of these mountains of water with small people coming down the side. It's just incredible. But it's right off the coast of Portugal. So pretty cool. Look at how intense and widespread this region of low pressure is. It's almost as if it's the Great Red Spot just sitting over the British Isles. And we had our deep Hudson Bay low, and now we have this low over the British Isles. This is transitory. This one becomes climatological. But this is just momentary. But a very impressive development. They had a really incredible week for them. So let's take a look at a couple of things in Vis 5D, Pete, and then I'll turn it over to Patrick. And that will have to do with searing. So this is the sea level pressure at 12Z on Halloween Day. And let's put the jet on top of there. I have the speed for that. And there it is. This is 60 knots, 60 meter per second or greater. And if you tilt it up, you'll see the evidence that Cyclone Center is to the south of the jet core. There's no doubt about it. So it's really kind of an interesting structure. And let's go back to the top view here. And let's take a vertical cross-section in theta. I forget if it's at this time or not. Now let's go ahead, take the speed off, just so I can get my bearings, and put horizontal theta, which is at 500 millibars. We'll take the sea level pressure off, and then put pressure on. That's also at about the 500 millibar level. So here's the little trophiness through which I want to cut this cross-section at the initial time. Notice, and these are 500 millibar streamlines in the kind of light green, white, and then theta in red, and so there's strong cold advection and strong cyclonic shear. So I'm trying to pick the right spot to see whether or not there's a strong upper frontal structure. So that's right over Newfoundland. Let's take a look at what that looks like. Oh, that's a pretty intense structure, don't you think? I mean, some of these isotopes are in the lower stratosphere at this level, and they're on the ground over the Atlantic Ocean over here. So this is a very intense front. I don't even think it's just an upper front. It's kind of a combined upper front surface front. So this is really deep and rare. This is a unicorn. You don't see this very often. Let's put the PV on top of there. And there's the downward penetration of the PV down to, I don't know what level this is, but it's probably about 600-ish millibars. Look at this wall of PV that separates the subtropics from the extratropics. And it's deep. It's hundreds of millibars deep, this wall. So sometimes you see a double structure. This one's just one step. So very intense. And then if we put the wind speeds on there, and maybe we'll take the theta off, we have an 80 meter per second jet right in the middle of this. And it's right where it should be, where the horizontal PV gradient is strongest. That's where you find the jet. And there's good physical reasons for that. And so that's a really nice picture. What I also did, I took it off. I thought for sure I would have seen, oh, this is a great upper front, and see the subsidence right under the jet core. It's not there. So I don't know why, but it's not there. So there's probably competing effects, and you don't see it. Let me just prove it to you. I got to do it now that I said it. Let's put W on there, but we have to go to the top and rearrange it because it's on the wrong place. So just slide it over here. Yeah, you got to find that invisible tag. Okay, so watch this. This is just the subsidence. Nothing. Nothing's organized in that cross-section. That's weird, isn't it? Ellen? Maybe the ridginess upstream or downstream has something to do with massaging the vertical motion field. I don't know. And I didn't calculate the temperature advection, but we saw it by eye. It's hard to imagine that it's not cold advection and in cyclonic shear. So I don't really know the answer to that. It's a bit of a mystery. But it's not well organized. And maybe my contour interval is a little too high, but it's the one I always use. So I've seen many structures that fit the bill with this contour interval, so I didn't cheat that way. So it just doesn't look that good. But the vorticity, or the PV that gets all the way down here, let's go to the top view again, Pete. And we'll take, let's take pressure off. And then put theta, not theta, QZ. I think I've got that on it. Yeah, so here's the vorticity. And it's, at this time at 500 millibars, it's not well put together yet. So this is just maybe the beginnings of this process by which you're going to start the stratospheric subduction and the vorticity generation. So that's maybe a clue. Maybe we're just intercepting this thing just too early in its life cycle. It could be just the beginning. So anyway, that's one thing that's interesting. Now let's go back to the sea level pressure and take everything else off the top. Yeah, we can leave the cross sections off for the time being. Just click ahead a few times. Let's keep going, I think. Look at how long it takes for this thing to really start to develop. Right here is about when it starts to go. Let's stop there and put the speed back on. The isosurface of the speed. No, the isosurface, please. Right at the jet exit region. And it's cut to the cyclonic shear side of the jet. It started on the other side. So there's the intensification. How about trajectories? And we have group 4. And then you better get out of trajectory so we don't take any by mistake. And let's tilt this up. Oh man, that's when the air starts to rise, when this cyclone squirts across the southern to the northern side of the jet. And that's the abrupt descent. For a long time, the air is just moving along over the ocean. And then suddenly, boom, it goes straight up. And I think it's in response to not only being in the right place with respect to the jet, but we can also go back to the top view and get the jet out of there now. See, she's made her point. And then vorticity, QZ, and theta. So let's get the trajectory up just for the time being and be ready to put it back in. But we know this is where the air is rising, right here. And so here's now in yellow the vorticity. Look at this head of high vorticity right there. In this point in the map, you can't really see the background very well. It's over just off the coast of France. And then the isentropes at 500 millibars are approximately, the thermal wind. They're approximate to the thermal wind, so there's strong PVA by the thermal wind there too. So you've got the jet circulation and the PVA by the thermal wind. Now a very well developed vortex structure. And I think I have, you slide down, Pete. Let's go to theta prime for the cross section. So is that a vertical cross section? Yeah. And let's back up a couple of times. Just one or two. Yeah, right in there. So I'm cutting through a much more robust upper vorticity maxima here just before the really strong development. Let's see what the structure looks like in theta at this time. And we're going to have to get rid of this one. That's W there. So that's still a very strong upper frontal structure. In fact, maybe it's more just an upper frontal structure now. It doesn't really have feet at the ground, just above the ground maybe. So that's a pretty intense upper front. I think PV is on the same cross section. Really narrow tongue comes down well below the level we're looking at the vorticity, and then finally the speed. I think we're at 60, 70, 80. So it's again 80 meter per second jet. But look at how strong the horizontal and vertical shear is in the frontal zone. Really nice. And this is just before the development ensues. As we put the trajectory back on, you'll see I think the air has not really started to rise much. Oh, it has. It's halfway through its rising, but it's all the way up to there a couple hours later. So it's all kind of coming together at this time. And this is in a different spot in space, but you can see through the cross section. So very intense development. All tied to our cold air passing through us over the weekend, really. That was the upstream condition that led to all this. So that's all I have. Pete, expert driving. Thanks again for a really great driving through this 5 feet. And that's all I have. Patrick?
We can stay on the Alicia Bentley maps for Pete. So I'm going to add to Sierran or Karen or whatever that storm name was, some stats on it too. Highest wind speeds, northwest France, 118 miles an hour. And those are wind speeds, those are gusts. 1.2 million people in France were without power at one time. It set pressure records in England, but also Wales, somewhere.
Yeah, middle of the island.
Yeah, somewhere right there. The Channel Islands, which are not on this map, but they're in the English Channel, had EF1 winds for over 3 hours. So imagine sitting in an EF1 tornado for 3 hours. It smashed windows, tore roofs. I don't know about the construction there. Probably older, that's an older part of the country, but still, imagine just having your roof torn off, from a storm. And then, like Professor Martin pointed out, another storm. This is Dominguez now, and if we could step back on this map just 1 or 2 clicks and go forward. So Sierra moved almost exactly through the English Channel. Let's just step through like 4 clicks. This thing does the exact same thing.
Yeah.
So there's no way you can recover from this event and do so in a way that's not going to be impacted by the second storm right after it, which is pretty wild. And like we touched on, it was almost the same development. It occurred, well removed from the coast of Europe. So it wasn't as strong as it made landfall, but almost the exact same thing. And if we stay on this map and click forward, we'll watch, here's a jet streak moving off of Canada and into the Atlantic. Let's just watch what goes on. Yeah. And keep going, 1 or 2 clicks. We have another development. Almost the exact same way we've seen 2 developments in a row now. The other ones happen more south. If we go back like 4 or 5 clicks, we'll just watch this. So here we have, one more please, Pete. We have our cyclonic disturbance. It's not even a disturbance, it's just a minimum in pressure, but it's on the anticyclonic shear side of the jet. So somewhere you would not expect development because you're not really tied to the entrance or exit region. In this case, you're just south of the jet. And so if we click forward 2 clicks, we see that storm move closer and closer to the jet. Something begins to develop, this jet gets stronger. We have a stronger exit region, stronger ageotropic divergence. We get development. We can see very strong baroclinicity in the thickness lines. At this time,
the thickness lines have a little bit more cyclonic curvature to them at the mouth of the Labrador Sea. So there's 500 millibar development going on behind the curvature too.
That's right, yes.
Which is interesting.
At this time, if we could flip to the 500 map, please, Pete. I'll put my cursor right where our minimum is. So we can see the winds were cyclonic. They're almost exactly mirroring this vorticity strip. And right here is where you have strong gradient and vorticity, strong PVA, right over where your cyclone is situated. And if we go back to the surface map at this same time, we're at 1,000 millibars. And let's see, we're at 12 UTC 6 November. So let's click forward just 1 day. So we'll get to 12 UTC November. This storm bottoms out, I think actually if we go back 1 is when it bottoms out. It is forecasted to bottom out below 950. Wow. And this is in less than a day. It goes from 1,000 to below 950 in a day. So this is fairly, not routine, but this is not unexpected for the northern Atlantic, but this is still a pretty strong storm, especially on the heels of 2 of them that impacted highly populated areas of Europe, which is pretty remarkable.
I wonder if there's a ferry that goes from Reykjavik to Thule or someplace on Greenland. I'd like to be on that ferry.
That would be great.
I'd like to be the pilot of that.
You could probably turn off the engine and just let the waves push you
downhill.
Yeah, straight towards Greenland. And I'm sure there's going to be wild amounts of snow. Nobody lives here, so it's not going to be realized. But you can imagine. I think there's actually precip on these maps.
I think that is the most heavily populated part of the island, though, actually, even though there's not a lot of people. But
true. Yeah, so this is all snow, and it's piling up on the eastern coast of Greenland.
Awesome.
And this is, this feature is taking up the entire North Atlantic, right on the heels of 2 extreme developments.
Yeah, and it's another example, Patrick, of how the tropics are involved in this thing.
Right.
Maybe less so in this one. This one seemed to have a more robust extratropical origin than the prior 2, but both of the prior 2, and even along the cold front, you can see the enhanced precipitation all the way deep into the tropics. That's so interesting. The tropics are bubbling up into the high latitudes here.
Right. I'm sure this is some AO Arctic oscillation pattern.
Yeah, it probably is a strong.
I'm not in a situation to say which one it is, but I mean you have a gigantic low pressure and then a gigantic high pressure on top of each other.
Angel is high.
And then the last thing I'll touch on, since we're low on time, we could go to domain and CONUS. there's going to be a development, we can kind of see it here. If we step backwards in time, and we'll stop right there, perfect. So this is now looking at 18 UTC, November 5th, so this is Sunday afternoon for our time. I'm not going to show anything before that because nothing happens over much of the eastern United States. And this is really the first disturbance to happen in a couple of days, and we see a minimum in sea level pressure. We have some flow from the south over our region, so we should expect to warm up. We'll be in the 50s, close to 60 maybe, over the weekend. And then we have a baroclinic zone, and this might be tied to that cold air advection we saw happening over the northern part of the states right now. And this baroclinic zone is just left over, and it sort of sits there. And if we step forward like 1 or 2 clicks, we can sort of see a development occur. And this, I'll show other maps at this time too, but what's interesting is we have this development. It's a fairly decent cyclone. I mean, it's nothing to write home about. We have strong warm advection over our region, but there's no precipitation forecast for us, which is interesting. All the precipitation is sitting well to the north of the system.
Yeah, my guess is, I don't want to steal your thunder,
Yeah.
maybe you have a guess. My guess is, notice the thermal structure in the thickness field.
Yep.
That's a lee-side trough, so the air has already been desiccated by subsidence. So there's nothing there.
Exactly right. Yep, that was exactly my point. All of the air down here, I mean, it's dry, it's been dry, it'll continue to be dry. And here's your strong baroclinicity, where you would expect frontogenesis to occur. The thermal structure, although it's warm, it's still largely spaced out compared to what's happening over the northern part of the country. If we could go to 500 at this same time, I'll put my cursor sort of on the northern portion. Largely the vorticity structure is scattered. There is, I think the resolution is playing tricks on us, but there's just a maximum in vorticity, and then downstream of it you would have a strong gradient of vorticity, and here's your PVA, but it's not occurring over over our region, it's well to our north, and over like Lake Michigan and portions of Ontario. And if we step forward from this view 1 or 2 clicks, we can sort of see the system maybe gets more organized, but it happens while we are not in this region where we would expect PVA about the thermal wind. We're sort of well removed from it, and we don't really get any sort of precipitation for our region, which is not a bad thing because, I'll end on this, if we could open another tab and go to the drought monitor, please. I used to always start my talks with this, so I'll end it today. So if you look over our region, we are not in a drought anymore. This is the first time since like May or April that we have not been in a drought. And Madison, maybe we're on the side of abnormally dry, but this doesn't count as a drought, this yellow color. It doesn't from the, that's technical terms. That's not me just embellishing. Moderate drought and anything else is actually a drought. This is abnormally dry.
Yep.
Portions in Iowa are dry. Maybe that'll change. I haven't looked at that, but we are not in a drought with maybe some precipitation, not from the system I was showing, but later on in the week. It'll be light, but we might stay in this abnormally dry period, not in any real drought concerns. But if we go back 1 click, one thing that has been happening is the deep south, Louisiana and Mississippi have been exceptionally dry for months. And from QPF forecasts, it looks like these will stay dry. And they get, heavy rain constantly, well more than us. So seeing exceptional dry, this is probably more realized than our 30 inches a year or whatever we get. They're more like 60, 70 inches of rain over the year. So
Isn't that one of the spots though with a robust El Nino that gets wet in the wintertime?
yes,
Or is it further east?
I think so. Yeah, with the El Nino, we can go back 1 click actually. We'll look at the United States. Yes, from the El Nino, it's projected that basically from Arizona to Florida will be abnormally wet, and then portions, well, just slightly to our north will be abnormally dry, but I can't say much more on that at this time. So any questions or comments about what I showed or something you want to see? Okay.
No, thanks, Patrick.
Thank you, John. Thank you.
There's
I'm on my way to Montreal at this time next
Okay,
week, so
so-
I'm not here.
Students have at it,
Yeah.
not just Patrick.